if vector u is equal to 3 and 1, vector v is equal to -4 and 2, we are asked to find question 1, vector u plus vector v, and question 2, vector u minus vector v. Let's see how we can solve this relevant problem. We are asked to find vector u plus vector v. Now, to look for vector u plus vector v, I want us to know that the tree under vector u is our x1, while the 1 is our y1, so we are having x1, y1. The -4 under vector v is our x2, while the 2 under vector v is our y2. So to add up this, our x1 is going to add up with x2, that's 3 plus -4, while our y1 is going to add up with our y2, that is 1 plus 2. Now 3 plus -4, positive times negative is negative, so 3 minus 4 is -1, then 1 plus 2 is 3. So this is how we add vectors. We are asked to get vector u minus vector v. Like we did in the previous example, our tree remains our x1, while the 1 is our y1. So for vector u, we are having x1, y1, while for vector v, we are having x2, y2. Now, since we are asked to subtract, it's going to be x1 minus x2, that is 3 minus -4, okay, then y1 minus y2, which is 1 minus 2. So negative times negative is positive, so 3 minus -4 is the same thing as 3 plus 4, which is 7, then 1 minus 2 is -1. We are given vector v to be 0 and 2, vector u to be -1 and 4, and vector w to be 5 and -3. Then we are asked to find vector w minus vector u, that's for question 1, and question 2 we are asked to find vector u plus vector v. Now, to get vector w minus vector u, we are going to substitute, okay, because w is 5 and -3, and u is -1 and 4. So we are going to substitute them, so it becomes 5 and -3 for w minus -1 and 4 for u. Okay, so what we did here was to replace w with 5 and -3, and to replace u with -1 and 4. So since we have replaced them, I want us to still know that our 5 is our x1, -3 is our y1, -1 is our x2, 4 is our y2. So our x1 will subtract our x2, while our y1 will subtract our y2. So we are having 5 minus -1, 5 minus -1, okay, that's for x1 minus x2, then -3 minus 4, -3 minus 4, that is for y2, y1 minus y2, -3 minus 4, y1 minus y2. So negative times negative is positive. 5 plus 1 is 6, then -3 minus 4 is -7. So this is the answer. So the second problem, we are still given this and we are asked to find u plus v. So we substitute. Our u is equal to -1 and 4, -1 and 4, plus our v is equal to 0 and 2. V is 0 and 2. So we are still going to note that -1 is our x1, 4 is our y1, 0 is our x2, 2 is our y2. So we are having x1 plus x2 and y1 plus y2. Okay, so we are having -1 plus 0 and 4 plus 2. So since we are having -1 plus 0, so by the time you add them up, -1 plus 0 is equal to -1, then 4 plus 2 is equal to 6. The sum of vectors remains the same irrespective of their order in which they are arranged. By the time we add up vector A and vector B together, and we get the same result as adding vector B and vector A together, it simply means vector addition is commutative. We all know that 2 plus 3 is equal to 5, and 3 plus 2 is also equal to 5. Irrespective of their arrangement, by the time you add them up, you still get the same result. So when this happens, we say vector addition is commutative. Now, if we are having vector A as 2 plus 5 and vector B as 7 minus 2, are we going to get the same result when we add A plus B and B plus A together? If we get the same result, it simply means vector addition is commutative. But by the time we add these two vectors together and we get a different result, it simply means vector addition is not commutative. Now, based on what we explained in the previous examples, 2i can be likened to be our x1 plus 5j our y1, 7i our x2 minus 2j our y2. Okay, so if we want to add up a plus b, you can just add up the i's together. So 2 we add up with 7, okay, and 5 we add up with -2. So this is what we have. If 2 is adding up with 7, it becomes 2 plus 7i plus 5 minus 2j. Okay, so 2i plus 7i will give us 9. Okay, then 5 minus 2j is 3j. Why is this negative? Because positive times negative is negative. So 5 minus 2 is 3. So a plus b is 9 plus 3. Let's see if b plus a will give us 9 plus 3. Now we are going to add this to this. So what we are going to do will be our 7 is going to add up with our 2. Y minus 2 will add up with 5. So when we do that, we are going to have 7 plus 2, which is 9, then minus 2 plus 5, which is 3. Okay, so we still have 9 plus 3. So a plus b is equal to b plus a. Since we have the same result, we conclude that vector addition is commutative. you can pause this video and solve the following.